So good morning. Good morning, students. Yes. So we will start with the class. Can any one of you tell me what and all we have discussed in the last class? You can just type the word title of that concept which we have discussed in the last class. Can any one of you? So what we have discussed in the previous class? Okay, we have discussed about compounds. Very good. We have discussed about the compounds. Okay, so what are compounds? So these are the substance which are made up of more than one type of atoms, right? So it will be made up of more than one type of atoms. I am using type, so that's where we have the compounds. Yes, we had compared this one with the molecules. We had compared this one with the molecules, right? So that's where we have discussed about molecules. What are molecules? So these are nothing but substances which are made up of more than one element. I am not using type, more than one element, right? Generally a compound can be called as a molecule. Generally, where we are talking it as glucose molecule, water molecule. So in that sense I am telling, fine. So that's where we have compounds and molecules. But what is common in these two? Both of them should contain more than one atom. Then only they can considered as compound or molecule. Yes, then we have discussed about properties. Then we have discussed about the properties of matter. Very good. Right? So that's where we have the physical properties. Then we have the chemical properties. All of you will agree? Physical properties means appearance. No need to add any reagent. No need to add any other molecule. So based on the observation we can tell. That's where we have the physical properties. That can be color or texture, or whether it can be state in which particular condition, liquid, gas, or in which form it is present, then melting point. So that's where we have the physical properties. But when I am talking about chemical properties, we have to use the reagent, other chemicals. Then only we can talk about chemical properties of that particular matter. Yes, then we have discussed about mass and weight. Very good. Then we have discussed about mass and weight. All of you are correct. Yes, all of you are correct, right? So that's where we have discussed about mass and weight, where mass will be a constant. For a particular substance, mass will be a constant, right? But when it comes to weight, it varies. It can vary depending on the altitude. If I take the weight of a person, it varies, right? So that's where we have the mass and weight. Say for example, I am in a lift, right? And lift is moving down. My weight will become, what will happen to my weight? It will become less, because along with the lift I am also moving down. But when the same lift is going up, my weight will increase, because I am putting the pressure, because I am moving down because of the gravitational force. But the lift is moving up. Now the weight will be different. So that's where it varies. Fine? Now, yes, all of you correct. Then we have discussed about density during that time. Even I discussed about volume. because density is nothing but mass by volume. Correct? So that's where we have the density. Right? So now we took the example of ice and liquid water. To explain this one, I took the example of ice and liquid water, and we observed how a volume is going to have the effect on the density. How the mass is going to have the effect on the density. Since density and mass, they are directly related. As there is an increase in the mass, density will also increase. Since volume and density, they are inversely related. As there is an increase in the volume, density is going to decrease. So that's what we have discussed in the last class, right? Now, yesterday you people asked, I have forgotten the name, I am really sorry. So you asked about problems on density. Okay? So anyway, I have got one problem. We will solve that and we will move further. Fine? Now all of you can write it down. A solution of water, a solution of water and salt, water and salt contains 25 grams of salt, 25 grams of salt in 250 ml of water. In 250 ml of water. What is the density of salt water? That is the question. Fine? All of you can see the board, okay? A solution of water and salt contains 25 grams of salt in 250 ml of water. What is the density of salt water? How to solve? They are asking to find out the density of the resulting solution. Right? So that's where, if I see this is question, now I am talking about the answer. Now whenever the problem is given to you, always remember, try to practice. First you should write what and all is given and what we know. What is that given information and what you know. So given data. What is that given data? Given data is mass of salt. They have given the mass of salt, that is 25 grams. 25 grams. Then what else they have given? Volume of solution. Volume of solution. How much? So that is 250 ml. That is 250 ml. So these are the given information. These are the given information. Stefan, we will see. Okay, these are the given information. Right? Now, what we have to find out? We have to find out density of solution. Density of solution we have to find out. Now, information which we know, it might not be given here, but what we know here is density of water. Density of water is equal to 1 gram per 1 ml. Right? 1 gram per 1 ml. That is the density of the water. Right? So that's what we have taken water as the standard. It's not required that they should mention that. It is understood. So density of water is 1 gram per 1 ml. What do you mean by that? That means if I take 1 ml of water, I will measure 1 ml of water. It will weigh exactly 1 gram. That's where we have the density. Mass by volume. Mass by volume. Since it is a liquid, they have mentioned it in terms of ml. Or we can mention it as 1 centimeter cube. Anything is fine. And gram is derived from kg only. Alright? Because 1000 gram is equal to 1 kg. 1000 gram is equal to 1 kg. So therefore, gram is the smaller representation of the kg. Fine? So that's where we have the density of the water. Now we will see. When it comes to density, what is density? Density is nothing but mass by volume. So density is nothing but mass by volume. Now, 1 minute, all of you are writing, okay fine, we will see. So when I am talking about density, that is nothing but mass by volume. Now whose density we have to find out? We have to find out the density of the solution, salt water solution. That means we should know the mass of salt water. That means we should know mass of salt water. They have not given the mass of water. Please remember, they have given the mass of salt. Now we have to find out what is that mass of water. Then only we can find out what is the total mass of the solution. Otherwise we are not going to get the answer. All of you are getting my point? So what is the density formula? So density is equal to mass by volume. Whose density we have to find out? We have to find out the density of salt water solution. Right? So that means we should know the mass of salt water solution. But they have given only the mass of salt. We have to find out the mass of water. Can any one of you can tell me what will be the mass of water under given condition? Question is here. Given data is here. Whatever we know, that one also I have written. Can any one of you tell me what will be the mass of water? Then only we can find out total mass of solution. Because the mass of salt they have given, we have to find out mass of water. Then if we add those two, then we are going to get the mass of solution. Can any one of you? What will be the mass of water? It's there. On the board only it is there. Might not be written directly, but it is there. If you observe it carefully, you will get the mass of water. Can any one of you? All of you, I think straight away you people have calculated. No, it cannot be 25 divided by 250. No, 25 is not the mass of solution. It is the mass of salt. They have not asked about mass of density of salt. They are asking about density of the solution. Anup is telling 1 gram. All of you will agree? Anup is telling 1 gram. It cannot be 1 gram. I will tell why. See, if I take 1 ml of water, it will give 1 gram. But here they have given 250 ml. They have given 250 ml. No, it cannot be 25 gram divided by 250 ml. That's what I am telling. No, that cannot be the one. Fine? So yes, now you are right. It should be 250 gram. Since density of water is 1 gram per 1 ml, therefore 250 ml of water will be 250 gram. 250 ml of water will be 250 gram. How we have found it? This one. For example, for 1 ml of water, it is 1 gram. Then how much for 250 ml of water? So ml will get cancelled. Answer will be in terms of 250 grams. So that's where we have got the 250 gram as the mass of the 250 ml of water. Fine. Now we have to find total mass of solution. Since there is no place, I am writing here only. You can write one below the other. So total mass of salt water solution will be 250 du plus 25. So 250 plus 25. How much it will be? 250 plus 25. So it will be, right, 275 gram. It will be 275 gram. Yes, it should be 275 gram. That is the mass of solution. That should come here. That is the mass of solution. Right? So volume will not change. They have given 250 ml of water. Volume will remain same. So therefore, density is equal to. So therefore, density is equal to 275 grams divided by, they have given 250 ml divided by 250 ml. So the answer will be 275 grams divided by 250 ml. Therefore, the answer should be, yes, 1.1 gram per ml. 1.1 gram per ml. You have to mention the unit. Without unit, you will going to lose the marks. You have to mention 1.1 gram per ml. If you simply write it as 1.1, here it's fine. I am talking about in your answer script. I am talking about. If you mention it as just 1.1, then you are going to lose the marks. You have to mention the unit. So it is 1.1 gram per ml. All of you have understood? So this is how this problem has to be solved. Right? Many of you, what we have done is, you have taken 25 divided by 250. But if you observe it carefully, 25 gram is the mass of, yes son, I am explaining. See, if you observe it here, a solution of water and salt contains 25 grams of salt in 250 ml of water. So what it indicates? It indicates that 25 grams of salt has been added to 250 ml of water. That's what the first sentence indicates. Right? Now the second sentence tells that what is the density of salt water? That means they are talking about the solution. What is the density of salt water? So in that case, what we have done is we have written the given data which tells that mass of the salt is 25 grams. Volume of the solution, because in 250 ml of water it will be dissolved. The resulting volume will be 250 ml. A slight variation in volume, we have neglected it. Fine. So volume of solution will be 250 ml. That is the one. Then they have asked about what is the density of solution, because salt water is nothing but solution. What is the density? Since they are asking about the density of the solution, we have to find out what is the mass of given solution. We cannot take 25 gram as it is. 25 gram belongs to only for salt. But they are asking about solution. So we have to find out what is the mass of solution. Then only we can calculate density of the solution. Otherwise we cannot. Fine. So to find out the mass of solution, we should know what is the mass of given amount of water. What is the mass of this 250 ml of water, which they have not mentioned. That is because it is understood. Since density of water is 1 gram per ml, that means if I take 1 ml of water, it will weigh exactly 1 gram. So therefore density of water will be considered as 1. Okay. So density of water is 1 gram per ml. So therefore based on that we can find out what is the mass of 250 ml of water. So for 1 ml of water it is 1 gram. For 250 ml of water it will be how many grams? So it will be 250 grams. Now substitute this value to find out total mass of solution. So total mass of solution will be equal to water plus salt. So that is nothing but 275 gram. So that is the total mass of solution. Now that one we can include here in this equation to find out the density. So therefore we have got 1.1 gram per ml. All of you have understood? Any doubt? Okay? All of you have understood? Don't worry. This type of problem they will not ask. Since you people have asked, therefore I have solved this problem. But it will help you out. Nothing will be wasted. Please remember. Knowledge cannot be wasted. Okay? Fine. So in that case, shall we move to the next one? Okay, so while finding out the density of a solution, please remember, while finding the density of a solution, we have to find out total mass of the solution. So total mass of the solution will be mass of solute, that is salt in this case, plus mass of solvent, that is water in this case. So all together it will give the total mass of the solution, which will be including mass of solute plus mass of solvent. All of you have understood? Shall we move to the next one? Okay. So fine, we will move to the next one. So we have terminology like precise, then accurate. We have terminology like precise and accurate. Now, as a PU students, we may not appreciate these words. We will feel, oh, what a headache it is. Why we have to study all these things? That's what as a PU students we are going to think. But as you go for higher studies, as you go for some research work and all, now I am talking about future. So that's where we will appreciate these words. Precise and accurate. Fine. See, for example, I am conducting an experiment. I am having one experiment. I am doing that one in a laboratory where I am expecting to get the result somewhere around 3. I should get the result as 3. Fine. Now, but due to some human errors, while doing the experiment, there can be some errors which can happen by the Raghavendra sir or any one of our human beings. Errors can happen, right? So due to that, I am getting the result as 2.9. Actual result I am expecting is 3. But how much I am getting? 2.9. Now what I will do? Oh no, I have got 0.1 less. I have got 0.1 less. So I will repeat the experiment. Just for your understanding purpose I am telling. I am repeating the experiment. Now when I am repeating the experiment, I got somewhere around 2.8. I have got somewhere around 2.8. Once again I will repeat the experiment. Now I am getting once again somewhere around 2.9. 2.9. Now I can tell that these values are precise values. These values are precise values because they are very close to each other. They are very close to each other and they are close to the expected value. They are close to the expected value. That's where I will call them as precise value. If I am doing an experiment, if I have got the value as 3, now this one I will call it as accurate value. This one I will call it as accurate value. All of you are understanding? No one will ask you this definition or no need to worry. So precise values are those which are close to each other and which are close to the expected value. But accurate value means these are the values which are exactly same to that of the expected value. So that's why we have accurate and precise, precision. Fine. So that's where we have the precise and accurate. Fine. All of you have understood. So therefore, now I am coming to one of the important concept. If you have understood this, now I will come to the one of the important concept which is important even for your exam point of view. So I will mention it as very important even for your exam point of view. For 1 mark, they can ask the question from this one. So that is with respect to significant figures. That is with respect to significant figures. So 1 mark question you can expect. They will give some values and you have to write what are the number of significant figures in those values. Fine. Now there are some rules which we should know. There are some rules with respect to significant figures. So what do you mean by significant figures? Significant figures means which will have some weightage, which will give some meaning. Without that one, it will not have any meaning. That's why they are called as significant figures. Okay? Say for example, if I am right, there used to one advertise, now it's not coming. Person will be dying, an old fellow will be on the bed, he is about to die. What his son will do is, he will write a check in his name and where he will mention like this. Where he will mention like this. And he is very happy because he is getting in crores. And while going to father's signature, due to the leakage, it's advertised from cement or something. Due to the leakage, water droplet will fall on this. When he cleans that one, because father has signed, just now father has signed and he is very happy. He got in crores. Next moment father is going to die. So he got the signature, he will get so much money. But to his fate, due to the leakage, one drop fell it on the zeros. So he rubbed it. To his surprise, it came like this. What happened? That became 2000. That became 2000. That shows that those zeros without some end point does not have any meaning. Does not have any meaning. So therefore, always what we will do, any amount if you write, we will make like this. Because there is no next zero. Nothing is there. It's a full point type. Or we can mention it as like this. Right? So what it indicates? So that means after this zero, nothing else. There is a full point. That's what that point indicates. Right? So that's what significant figures. That's what we are going to discuss now. Fine? Now when I am talking about these things, we have some of the rules. How to find the significant figures for a given value. That's where we have some rules. According to that, it tells that all non-zero digits are significant. All non-zero digits are significant. Got my point? Say for example, if I have mentioned 999, so that means it is having 3 significant figures. It is having 3 significant figures. Fine, it is having 3 significant figures. If I am mentioning 234, then also it is having 3 significant figures. So that's what it indicates. All non-zero digits are significant. All of you have understood? So next point tells that zeros present between the non-zero digits are also significant. Zeros between the non-zero digits. Between the non-zero digits are significant. Zeros between the non-zero digits are significant. So if I take example 1001, in that case how many significant figures should be there? All non-zero digits are significant, no doubt. And zeros between non-zero digits are also significant. In that case, how many significant figures are there in 1001? Can any one of you? Yes, it should be 4. It is having 4 significant figures. Very good. It is having 4 significant figures. Right? If I am making it as 900201, how many significant figures in second case? Yes, all of you are correct. In second case, how many? 900201. Yes, very good. They are having 6 significant figures. They are having 6 significant figures. Good. So we will move to the next rule then. You people have understood this one. All of you are correct. So we will move to the next one then. Okay? Next rule tells that zeros preceding the non-zero digits are not significant. What do you mean by preceding? Means coming before. I can mention zeros before to the, either preceding or before to the non-zero digits are not significant. All of you have understood? They are not at all significant. Say for example, here zeros preceding or before to, anything is fine. So preceding the non-zero digits are not significant, or before to the non-zero digits are not significant. Say for example, I have 0001. How many significant figures are there in this case? 012. There are significant figures, Stefan. It is there. In this case, how many significant figures will be there? Yes, 1. It will be having 1 significant figures. As Stephen has written 012. Yes, there is a non-zero digits. So therefore it will be having 2 significant figures. So what I mean to tell here is zeros before to the non-zero digits are not significant. 0 before to the non-zero digits are not significant. Therefore, we will consider only these 2. Here this one only we are going to consider. Fine. So now even if I write 0.001, how many significant figures will be there? Once again it is 1 only. Once again this will be 1 only. Because whether a decimal point is there or not, that is secondary. But these zeros are before to the non-zero digits. Therefore, it should be 1 significant figure. Fine? All of you have understood? So this is one point. Another important point. So we will come to next one. We will come to next one. Zeros after the non-zero digits, without a decimal point are not significant. significant. Observe this statement carefully. Now, example. What is that amount or money your father gave for today's expenditure? If I tell 100 rupees, if I write like this, it's actually wrong. 100 rupees, normally what we will do? We will mention it like this, right? So 100. For day to day, this one we are going to mention like this. But in reality, with respect to scientific, this one does not have any meaning. That means it shows that how many significant figures are there? Sahana, read the statement. Zeros after the non-zero digits without a decimal point are not significant. So what it means? It means that these zeros does not have any values. So therefore, it will have only one significant figure. It will have only one significant figure. Fine? All of you have understood? Now I will mention zeros after the non-zero digits with a decimal point. With a decimal point are significant. With a decimal point are significant. That means same thing. If I mention it as like this, how many significant figures are there? 100 dot. How many significant figures are there? Stephen, I will come to that. No, it cannot be 3. It should be more than 3. I will come to that. In this case, it is having 3 significant figures because there is a point. So 1, 2, 3. So 3 significant figures. Zeros after the non-zero digits with a decimal point. All of them are significant. Say for example, if I mention 100, 0, it will have 4 significant figures. It will have 4 significant figures in this case. If I am writing this one as 100.00, it will have 5 significant figures. It will have 5 significant figures. That is because even after decimal point, I am indicating 2 zeros means that's where I am going with accuracy, precise. For example, I want to get the value 300, right? Now I am getting the value as 2.90. Another way I am getting the value as 2.809, right? So that means these zeros indicates up to 2 decimal place value should be 0 only. Up to 2 decimal place value should be 0 only. But here it is becoming 9. But here up to second decimal point there is a 0. So therefore based on that we can have the precise and accurate numbers. So therefore whatever zeros after the decimal point with a non-zero digit over here, so all of them will be a significant figures. All of them will be a significant figures. All of you have understood? Now if I go with Stephen has written 1, so that is 123.30. 123.30. How many significant figures are there? Any one of you? In 123.30, how many significant figures are there? Any one of you? Oh, okay, already people have written. I'll come to that. 0.0, no significant figures are no. 0.00 does not have any significant figures. There is no non-zero number. Therefore, it does not have any value. Okay, you people have written 5. Yes, absolutely correct. It will have the 5 significant figures. It will have the 5 significant figures. Absolutely correct. And 0.00, no significant figures because it does not have any value. Right? No significant figures in 0.00 because there is no non-zero digits. Okay? So that's where we have the rules to find out the number of significant figures in a given value. All of you will agree? Okay? Now I have a condition. Where I can tell that where I have 3 pens. I am defining, it is defining. I have 3 pens with me. So that means I can mention it is like this, or I can mention like this, or I can mention it like this, or I can mention it like this. So what I mean to tell here is, when I am defining with some accuracy, then they can have, so I can tell infinite number of significant figures because I can mention any zeros over here. Since all of them are after non-zero digits with a decimal point, therefore all of them will be significant. So I can have infinite number of significant figures. When I am talking about with definite this one, when I am telling I have 3 pen, that means it can be written like this, like this, like this, like this, whatever it might be. So therefore they can have infinite number of significant figures. All of you have understood? Any doubts? Any doubts in this regard? So these are some of the important points with respect to your exam point of view also. Okay? Fine? So therefore, if someone is telling, I have so many values, right? So that means 3.0, yes, still. So yes, still it will be having infinite, but there I am not defining, but you have mentioned like this 3.00100, yes, all of them will be significant figures. All of them will be a significant figures because after decimal point these values are there. All of them will be a significant figures. Fine? Okay. Now I am mentioning like this. For example, I am writing a checkbook. I am writing on a check slip. I don't have that much amount. Fine. Okay, now. So based on that, I can have these many. Okay, it will come somewhere around 10 lakhs. Right? Now that is fine, where I have to mention about these things. But the same thing when I am going with scientific studies. Where by mistake I had written like this. So therefore, to avoid this mistake, all these mistakes, what I will do is, I will mention it as 1 into. 1, 2, 3, 4, 5, 6. So I will mention it as 10 to the power of 6. Got my point? So I will mention it as 10 to the power of 6. That's what I told. It is a scientific notation or scientific representation of a particular value. When we have the large value, 100, we will write it as 10 to the power of 2. It's very simple. So 1 And how many zeros are there? That one should be raised to the power of 10. That's all. So 1, 2, 3, 4, 5, 6. Don't consider this 0. So it will be 10 to the power of 6. Okay? So here it will be 1 into 10 to the power of 5. So like that we can have the scientific notation to avoid the errors, to have the accuracy, to have the significant figures. In this case, it is having one significant figure, that is this one. It is having one significant figure, that is this one. This one is a representation, scientific representation. This one we are not going to consider in the significant figures. So this will be a significant figure. Therefore, it is having one significant figure. Same thing I can mention as 1.0 into 10 to the power of 6. Now it will be having two significant figures. It will be having two significant figures. So that's where we have the scientific notation. That's where we have the scientific notation. All of you have understood? Any doubt? Any doubt in this case? Okay? So fine. So in that case, we will move to the next one. While solving a problem, with regard to significant figures, they can expect the question in your exams. It can be competitive exams or board exam. 1 mark question will be there for board exam. Okay? But next one, it is all required when you are solving some of the problems in future in physical chemistry. Say for example, I have 2 into 10 to the power of 2, right? So 2 into 10 to the power of 2, which is multiplied by 3 into 10 to the power of 4. I have to solve. While solving, I got this particular value. Now further I have to solve. How to do that one? Then I have to take that 3 into 2, right? 3 into 2 multiplied by 10 to the power of 2 plus 4. 10 to the power of 2 plus 4. Then you should not multiply 2 and 4. No. It should be added. It should be added. So 2 plus 4. That means final answer will be 6 into 10 to the power of 6. 6 into 10 to the power of 6. All of you have understood? 1.245. No, Stefan. 1.245 into 10 to the power of 6 will have 4 significant figures. Will have 4 significant figures. Fine? Yes, Anup, you are right. It will have 4 significant figures. You should not forget about this one. This is a scientific representation, no doubt. But this one you should not forget. So that's where it will have 4 significant figures. Fine? So that's where we have the calculation. This is how it has to be solved. Now same thing means another value I will take. While solving the problem, we got the condition in such a way that 4 into 10 to the power of 4 divided by 2 into 10 to the power of 2. Now what to do? How to solve? So this can be like 2 ones are 2 twos are. So 2 into 10 to the power of 4. This one I am taking it up, therefore it will become minus 2. 4 minus 2, because when it will go up, it will become 10 to the power of minus 2. Right? Therefore, 2 into 10 to the power of 4 minus 2, that means 2 into 10 to the power of 2. Fine? Anup, which one? Okay, fine. This one, right? So, while solving the problem, it might be in physics or in chemistry. Any of these, when you are solving the problem, there can be a step where you will come across these type of values. I have taken a simple values. These type of values you will come across. Now whenever there is a multiplication, because inside the bracket and another one is also inside the bracket, that means these two has to multiply with each other. Fine. So during that time, what I will do is, whatever scientific representation I have done, that will be solved like this, where 2 plus 4, I should make it as superscript value, I should make it as add. I should add it up. And whatever is there, this one should be multiplied. So it will become 6 into 10 to the power of 6. But the same representation, if I make it like this, division. So in that case, whatever scientific representation is there, whatever superscript values are there, it will become minus. Because we have 10 to the power of 4. Now when I will take it up, it will become 10 to the power of minus 2. Now if I add it, 10 to the power of 4 plus minus 2. That means 10 to the power of 4 minus 2. So that's what I have written directly. That's all. That's what I have written directly. If instead of 2 here, if it would have been minus 2, that means 4 into 10 to the power of 4 divided by 2 into 10 to the power of minus 2. Now it will become 2 ones are 2 twos are. So 2 into 10 to the power of 4 multiplied by 10 to the power of minus 2. Plus 2. Because minus 2, when I take it up, it will become plus 2. So therefore 2 into 10 to the power of 4 plus 2. Got my point? So that's where we should have the clear observation while solving the problems. All of you have understood? Whether I am clear now? So these are some of the values we will come across very often when you are solving the problems in chemistry or in physics, especially in chemistry. Fine? All of you have understood? Any doubts in this? Shall I move to the next one? So in this case, significant figures, they are very important from your exam point of view. But these are some of the concepts which we should know to solve or to utilize in future. They may not ask directly. Write the answer for 2 into 10 to the power of 2 divided by 4 into 10 to the power of minus 2. What is the answer? They will not ask. But it will be utilized while solving the problem. Fine? But significant figures, yes, they have asked many times. Okay? Now, whatever next I will be telling, once again I will call them as very important. Another 5 minutes. Okay, don't worry. So, very important. That is atomic mass unit. Atomic mass unit. We can call it as AMU, or we can also call it as Dalton unit, or Dalton, simply as Dalton, DA, or unified mass, U, anything is fine. Atomic mass unit or Dalton unit or unified mass, one and all same. Right? Say for example, if you ask what is the mass of or what is the weight of Raghavendra sir, or to be more appropriate I will ask what is the mass of Raghavendra sir, then I can tell that mass of Raghavendra sir is secret. So it will be somewhere around 65 kg, right? But that is a value which can easily present, we can easily find it out. But when I am talking about an atom, which is a very, very minute particle, right? It's a very, very minute element. So it's very difficult. It will be having very, very low mass. So therefore, that's where we have some way of representing the mass of the atom. And one of the methods is, earlier they used to follow, is atomic mass unit or Dalton unit or unified mass. Okay, so if I want to define, that's where definition they will ask. If I want to define, atomic mass unit is nothing but it is the mass equals to 1 by 12 of carbon 12 isotope. It will be equals to mass of, okay, I will include here, it will be equals to mass of 1 by 12 of carbon 12 isotope. How to define the atomic mass unit? We can define it as it is the mass equals to mass of 1 by 12 of carbon 12 isotope. Give me 2 minutes. Say for example, I have a dosa or chapati or whatever it might be, whichever you are fond of. Okay, so I have one particular dish with me and I have total, not here, I am telling, I have total around 12 students. I have total around 12 students and Raghavendra sir is impartial, right? So therefore what he will do is he will divide this particular thing into equal 12 parts. But don't worry, I am not good in drawing. There can be unequal parts. So 1, 2, 3, 4, 5, 6, 7, 8. Now 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10. Okay, another. Okay, so 11 and 12. So total 12 parts are there. So don't say, sir, 9 and 4, they are equal parts, sir. Okay, think that all of them are equal in size. Now, among these 12, any one part is nothing but 1 by 12. It is nothing but 1 by 12. 12 division alli one division, that is nothing but 1 by 12. That means if I consider this one as a carbon 12 isotope which has been divided into 12 equal parts, then among that any one part, what is that mass? That is nothing but atomic mass unit. So what is atomic mass unit? It is the mass equals to 1 by 12 of the carbon 12 isotope mass. Fine, all of you have understood? Any doubt in this? If you have not understood this one, you can ask. Anyway, I am stopping here. So that's where we have the atomic mass unit. It's a bit important definition. So what is atomic mass unit? It is the mass which equals to the mass of 1 by 12 of carbon 12 isotope. What are the other names? It can be Dalton unit or unified mass. Anything is fine. Okay? Okay, Yagnesh. Spelling mistake. You have written, ma'am. Okay, no problem. So I will stop here. While coming tomorrow, please go through whatever has been done in today's class. Okay? And if you have any doubts, you can ask even tomorrow also. No problem. Fine? Okay, if you want me to repeat the definition, right? So atomic mass unit is nothing but it is the mass or it is a value which equals to the mass of 1 by 12 of the carbon 12 isotope. So what is atomic mass unit? It is a value. So that value should be equals to mass of carbon 12 isotope, not complete carbon 12, 1 by 12 of the carbon 12 isotope. So that value is nothing but atomic mass unit. Fine, Ullas, now it's clear? Any doubts? Okay. Okay, okay then. I will stop. Take care. Bye. Hmm?